Hello, let's continue our Sudoku adventure with Conversation Starters by rockratzero. So, we have normal 6x6 Sudoku rules, which means in every row, every column, and every 2x3 box, we are putting the digits 1 to 6 exactly once each. Additionally, this gray circle is an odd number. You can remember that because it looks like an O, and O is odd. That's one way to remember it. And this square is an even number. Square has an even number of sides. That's the way I remember that. All right, and we have, these are not killer cages. These are what are called look and say cages. So what does that mean? Well, first of all, you can repeat digits in the cage. So, I mean, as long as other Sudoku rules allow it, you can just repeat digits. It does not have a non-repeat rule. Additionally, this is not a sum. Instead, this 1-6, for example, you're going to read that as 1-6, which means that this cage has exactly 1-6 in it. Not 2, not 0, exactly 1. And then this cage here will have exactly 4 1s in it. So you just read it in that order. All right, so those are the rules. And if you would like to try the puzzle yourself, which I highly recommend, click the link in the description. And I am going to get started right now. All right, well, obviously we can start by just filling out the even and the odds here. Also, this 4 1s really stands out to me. One thing we can definitely say is this formation here spans exactly 4 rows. So because it spans exactly 4 rows, how many 1s are in 4 rows? Well, there are 4 1s in 4 rows. And so if there are 4 1s in this cage and it is a subset of those 4 rows, all of those 1s go in this cage. So we can't have any 1s outside of the cage. And so that means in this row, for example, 1 can only go here. We can also say that this cage spans 4 columns. And so here we already have a column with a 3. So we need 3 more 1s in these 3 columns. And so that means that the 1s must also be present only in these columns within the cage, which means this one needs to be a 1. And then finally, we have 1s here and 1s here, which we can't yet resolve. These ones do look up, removing 1 from this odd square. All right, so what else can we do? Well, this has 3 4s in it, and we have something similar going on. We span 3 rows. So for this row, this is the only place that can have a 4. And then now in this row, now this is the only place that can have a 4 because we don't want to repeat in the column. And for this row, there's going to be a 4 in one of these 2, which takes a 4 out of here. This 2 5s, we could have just done that from the start. There's only one way that's going to work, is 2 5s right there. That does place a 3 here. All right, what else can we do? 2 2s. Well, again, we have 2 columns here. So one of the 2s is going to be here. The other is going to be up here. All right, so where do we want to go from here? There's 1 6 in here, but I don't quite know where it goes, and I don't think this limits things enough yet. Okay, well, I think we should just start filling candidates then. Oh, one thing I can say is there's a 2s here, there's 2s here. So where are 2s in this box? Only right here. That makes this a 6. So we know the 6 in this box is not in these 2 cells, but that doesn't help enough yet. All right, so what else can I see? Oh, I need this 1 and 5 need to go down here somewhere, and there's a 1 here. So this is 5 and 1. That leaves a pair, so we need a 3 and a 6 here. That means this is known. Yeah, it's going to be a 2. And then this is going to be for 3 and 4. Oops, 3 and 4, but we know the order because of this 3. Very nice. So almost finished these 2 bottom boxes here. Next we have a triple here. So we need a 1, we need a 3, and we need a 4. We can already see that the 1 and the 3 see here. So that's a 4, that's a 1, that's a 3. Those are all done. How about the triple here? So we need a 1. It's going to go here because we know it's in one of these 2. We also need a 2 and a 3. Well, the 2 and the 3 don't... Oh, no, sorry, we don't need a 3. We do need a 2. That's in one of these 2. And we need a 6. One of these. Okay, so that did not get resolved as far as I can tell. Okay, what else do we want to do here? This is a 3 or a 6. Ah, and it can't be a 3. So this is 6, this is 3, this is 6. Could have seen that earlier, but I just noticed it. Okay, this 6 here takes it out of these two. So we know that there's a 6 in one of these two cells. And that's going to fulfill the 6 for this cage. So we have 1, 2, and 6 accounted for. So these two cells are going to be 3, oh, and 4 as well. So these two cells can't be 1, 2, 4, or 6. So we're down to 3 and 5, and they go like this. So this is going to be 2 and 4. So this is the 2, this is the 4. And in fact, we have vertical roping here. So we know we're going to have 3, 5 over here. There's only one way that goes because of this 3, 5. And we know this is going to be 1, 6. We don't know the order of that. But we can see here that we place this 2, which makes this one the 6. This is 1 and 2, 6 and 1. That's not a 6. We do not have vertical roping here, so we can't use that trick, but we just fill the rows. So it's not a big deal. This is a 2. This needs a 5. We need a 4, and we need a 6. All right. Well, thank you, rockratzero, for the demonstration of look and say cages. This was a neat puzzle. I liked the use of coverage here, where, for example, we knew that there were 4 columns. 4 columns could completely cover this 4-1 cage, and 4 rows could completely cover it. And that immediately gave us these 2 ones. So that was neat. We had something similar going on with the 4s in here. And of course, this demonstration here maybe would have hinted you that you can do that with larger formations, as well as this one here. So very neat. Got some digits right away. So yeah, hope you all enjoyed this puzzle and my solve. And if you did, then why not leave a like and subscribe?